When electrical current is flowing through a wire, there is always opposition to flow of electrons, or we can say opposition to flow of electric current. This opposition to electrical current is nothing but called resistance. The resistance of a conductor depends upon the two factors. One is length of the conductor and cross-sectional area of the conductor. Resistance of material also depends upon temperature and nature of material. But in today's topic, I am going to talk about dependency of resistance on the length of the conductor and cross-sectional area of the given conductor. So let us talk about the meaning of specific resistance. Now, to understand the specific resistance, let us do one experiment before proceeding further. We got here a ohm meter. Ohm meter can measure the resistance of given material. Consider a conductor of length L and cross-sectional area equals to A square units. Now ends of the conductor connected to ohms meter as shown in the diagram. And suppose the reading of resistance in the ohm meter equals to 25 ohms. Now let us increase the length of the conductor. Let us assume we double the length of the conductor. So the new length of the conductor becomes 1 plus 1 equals to 2 meters. Now connect other end of the ohm meter to the end of the new conductor. Now the resistance measured by the ohm meter equals to 50 ohms. Here length of the conductor has increased. The value of resistance also increased. The value of the resistance is shown in the ohm meter. Now let us again increase the length of the conductor. Let us say by 1 meter extra. So the length of the conductor has become 3 meters now. Now connect end of the conductor to the ohm meter as shown. Now the reading shown by ohm meter equals to 75 ohms. If we do not change the temperature and if we do not change the type of material, that means as long as the temperature and nature of the material maintain at a constant, the resistance value increases as the length of the conductor increases. First, we had 25 ohms for the length 1 meter. After that, 50 ohms for the length 2 meters and 75 ohms for the length 3 meters. Here, the resistance value keep on increasing as we keep on increasing the length of the conductor. Thus, the resistance value is directly proportional to length of the conductor. Let me repeat. If L is the length of the conductor and during the experiment, if I do not change the nature of material and I do not change the temperature. Here, nature of material means if I am performing the experiment by using copper wire, so during the experiment, I should not change the metal. I should not change the metal from copper to silver or silver to any other material. As long as I do not change the metal and as long as I do not change the temperature of the material, then resistance is directly proportional to length of the conductor. Till now, I performed the experiment by changing the length of the conductor. Now, I perform the experiment by keeping the length constant but changing the cross-sectional area of the given wire or given conductor. Here, why I am using the conductor? Because conductor cannot be only the wire. Wire is one of the example of conductor, but conductor can have any shape, round shape, rectangular shape, rod shape, or any other suitable shape depending upon the device you are using. So here we are using the word conductor instead of wire. So let us now perform the experiment by changing the cross section of given wire, because we selected here conductor in shape of wire. If you select a conductor in shape of cube or rectangular or a rod shape, then accordingly the diagram and accordingly the cross sectional area will be changing. Here, to make you understand, I have selected a wire instead of selecting a complicated shape. So let us now perform the experiment by taking a wire, and now we change the cross sectional area keeping the length of the conductor constant. So let us perform the experiment and see what would be the result after changing the cross sectional area of the conductor. Now consider the length of the conductor equals to 1 meter and cross sectional area equals to a square units, a square meters. Now connect other end of the ohm meter to the end of the conductor and let us see what is the reading of ohm meter. Ohm meter is showing 40 ohms. Now let us change the cross sectional area and see what happens. Now let us reduce the cross sectional area by half. So new cross sectional area half of the original. Now connect other end of the ohm meter and see what is the reading. The reading shown by ohm meter 70 ohms. In this case, the wire has become more thinner compared to earlier case. As the wire becomes thinner, wire or a conductor becomes thinner, the resistance value increases. Now connect other end of ohm meter to the end of the conductor and let us see what is the reading of ohm meter. Ohm meter showing 110 ohms. Here I would like to clear one thing. The values of ohms in the ohm meter I have taken randomly to make you understand. Here we observe that as the wire becoming thinner, the resistance value is increasing. Resistance value of a given conductor inversely proportional to the cross-sectional area of the conductor. From above discussion, it is clear if temperature and nature of material remain same, then resistance of a given conductor directly proportional to length of the conductor. Let us call it as equation 1. Also, resistance of a conductor inversely proportional to the area of cross section. Let us call it as equation number 2. Now combining equation 1 and 2, we get R is proportional to L upon A. Now to remove the proportionality symbol, R equals to L upon A multiplied by some constant rho. Rho is called specific resistance of given material. Specific resistance is also called as resistivity. Now, simplifying this equation for rho, we get rho equals to Ra upon L. From this equation, we can define specific resistance. If A equals to 1 square meter and L equals to 1 meter, then rho equals to R. Now, let us define specific resistance. The resistance of a given piece of material having unit length and unit cross-sectional area is known as specific resistance, also called as resistivity. How do you find my presentation. If you like the presentation, please subscribe the channel and forward it to the friends. And give me your feedback. How do you find and what are your suggestions to improve my videos in coming future? I will come with another video another time. Till then, bye bye, see you. Before going, I would like to announce one thing, that everybody thinks trigonometry is a difficult subject. Trigonometry is very tough. It's difficult. To come out of this fear, I produce a video in cartoon form on trigonometry. I request you that you watch this video and give me feedback. The thumbnail of video I shown here, मिस्टर ट्रिगो ने सिखाई ट्रिग्नोमेट्री और पूरे स्कूल में हंगामा. I hope you will watch and enjoy this video. Till then, bye bye, see you, meet you again with another video. Enjoy yourself. Bye bye.